All right, so for this next session, let me turn on my video. For this next session, we're going to continue on our lessons learned from previous exploration, and our first talk is by Ben Feist and co-authors on Lunar EVA Science Support Operations, learning from Apollo and Shuttle for application to Artemis. Take it away, Ben.
There we go. Okay.
Yep.
So Apollo 14, you can see in this diagram how mission control hierarchy was structured. And you can see that the lunar geology experiment that you heard about earlier is situated here. And it was the only experiment that wasn't an instrument, but it was treated as a peer to the other instruments that worked, to the other experiments that were instruments in the LSEP package. And this caused kind of some interesting problems that I'll talk about. They reported into the experiments officer that then communicated into mission control. And on Apollo 14, there was, this is someone else's comment, an undisciplined science support operation that led to some corrective action. And here's a quote from Lee Silver, that when we got through with Apollo 14, Dave Scott, commander of Apollo 15, said, "Lee, that is not going to happen on my mission." And you can read the rest of this quote later on. But Jim Lovell was introduced then as the top man in the science backroom. And this all took place in Building 30 of Johnson Space Center. And here's a diagram of the third floor of Building 30, and you can see mission control in the center. We're talking about the science support room, which is on the bottom right here. And this is a little room with a console in the front and a few desks. And here are the people that were working on the Apollo 17 lunar geology experiment. You can see Bill Muhlberger sitting here. He was the lunar geology experiment PI. And Dale Jackson sitting next to him. He was the support coordinator of the LGE. And we have Lee Silver and Jim Head, who we just heard from in the last presentation, who were the LGE advisors. Bill Muhlberger described this as the four-man voting team, with Bill having the last say, being the PI. Everyone in this room had a role, which is really important to remember. In Bill's own words in his oral history, he describes that we were all sitting at a table with a map laid out in front of us, and sitting next to me was Dale Jackson, who was my immediate science czar. He didn't have to fight Jim Lovell to get things done or worry about those tasks. He was thinking about what was the science that was getting done and making sure that I got it done. So here's Jim Lovell, that science team leader that we heard about before, who was that corrective action after Apollo 14. He was the perfect selection for this because he had distinguished himself in the field geology training, as was just mentioned in the Q&A. So he had the respect of everybody in mission control and in the science community. He was essentially the scientist wrangler across all the LGE and the other LSIP stuff, and you'll be able to see him in action in a moment. Here we have the experiments officer, who was responsible for everything, LSF and LGE, in terms of communication into the mission control room. Okay, so now you know who the people are. Next, I'll show you the different scenarios about how decisions were handled when you had to make deviations from the flight plan. So here's a first example for a simple communication, where you can see in this chart on the left the diagram of Dale, Lee, Jim, all advising Bill, who then goes through Lovell to make choices. And in this footage, you can see that they had just discovered ore and soil at Station 2 on Apollo 17, and a new priority list is being put over on this overhead, this light table, that had a TV camera pointed at it that basically put it up on screen 2 in the mission operations control room. So everybody, Capcom, flight director, everybody could see what the science room thought the new priority should be. So this is a great example of an early information system that's not verbal, not going through the regular comms over headsets, that just let information be known after discussion in the back room. Now, for more complex things, we have a much more difficult situation. So we have Lovell, who's that clearinghouse. You can see him here talking to the LSEP in this diagram, as well as the LGE people, and then this really complicated structure to get information to the Capcom and to the crew. This allowed for more complex handling, and it solved the problem on Apollo 14, but it introduced slow communication, reduced detail into mission control and therefore to the crew, and it left many granular decisions to the crew and the Capcom, which you'll hear about later in Noah Petro's presentation. So I have a recommendation, and I'm happy to say that it complements the other things that we've heard about today, to introduce a new position in mission control called the Exploration Science Officer. So this is somebody who is both Bill Muhlberger and Jim Lovell rolled into one. Now that might seem like an unrealistic ask, But NASA has personnel that already meet these criteria. And so this would be a scientist who is trained as a flight controller, capable of providing informed real-time triage. This could be the same person as the Artemis project scientist, but it doesn't necessarily have to be. This person would coordinate with field PIs, who are those geologists who are on the surface, who hopefully are on every flight. And this idea of a field PI is something else that you'll hear Noah talk about later today. And this, you have to leverage modern information systems and data systems in order to make this kind of role work. There's a lot of work that would go into this ESO, and you need to make sure that the information is present and clear. And you'll hear tomorrow Matthew Miller talk about some of the information systems that we're making to do exactly that. And Cameron Pittman talked about ways we can enable scientific data for real-time use in the backroom. Now, try to keep this idea of the ESO in your head while we go through this next section. So here, the old storytelling rule is show and don't tell. So I'll stop telling you. And what I've done here is I've synced up 16 millimeter footage of the Apollo 17 backroom that was filmed during Apollo 17 and with the audio that was actually in the National Archives in College Park, Maryland. So here you can actually see them and hear them talking. And the scenario that you're about to watch is they had planned to go to Emery Crater, which is a large, deep crater, several kilometers to the south of the landing site, and spend an hour there sampling excavated blocks that they could see in photography that were on the rim, and then return in time to destroy the surface electrical property experiment. Now, as you watch, imagine that Bill and Jim Lovell are one person on Artemis.
Take a look at Station 1 and find out, you got 20 minutes less than you have normally to play with in Station 1, so you might want to review that a little bit.
Yeah, we're going to have 21 minutes less than we had.
You might want to just kind of look ahead,
Yeah. Well, we went 66 to 45.
Station 1, we hope.
Station 1 got boulders of all sizes around.
And I've got a card already up for it
We're going to be back.
somewhere.
Bill, you realize that Station 1 is getting cut back to 20 minutes now?
Is it a walk back constraint on that oxygen?
Which they know we can get to. Or to try not.
Riding is very good.
Hey, Jim.
No, our original plan was to go ahead and go to Camelot. We couldn't get to.
But they've cut us to 6 plus 45, and we're 25 minutes late.
Hey,
Fill us in on all the sort
let's
of
talk
details.
about stop one to more great detail. It takes 20 minutes to drive out there. With the walk back constraint and being late the way we are, we only got 18 minutes at the most to be there anyway, regardless of how much time was cut off to the end of the EVA. Now you might want to change your EVA 1 stop to that Big Rock or some other spot that you...
Okay.
Well, we got to have a decision here very shortly.
How much time?
Okay.
Argue. Come on in here.
We haven't left one yet.
I'd rather go to Rudolph.
We're going to get an update on
Rudolph's a total unknown. We don't know whether there's a block there or not.
Are they going to get through to the subfloor of Rudolph?
No, they won't.
Hey, Jim.
That's the real problem.
But you know you're giving up a chance to get into one of these big craters. But the only one that even comes close to it there is Trident. You got 2 blocks. You got 2 big blocks.
Well, we're looking at it right now. I don't think...
One's on the rim.
One's on the rim. Those are on the near side, the most effective side.
That or
blocks
sure,
are on the
what about
inside.
that?
It's,
Well, as far as I know, yeah, he went back to...
We're not gaining much. Remember when we moved to Sherlock? We gained about 6 or 8 minutes driving time. We're cutting from there to that one.
Well, if
We're
we
looking
can't
for
go as
some place
far
that
as
doesn't require
Camelot,
20 minutes
I'll
to
vote
drive to.
I think Trident's our best.
those 2 blocks on the north rim of Triton.
Funny, they never mentioned it when they were back there at the left. The only big block we've seen is
Well,
one
maybe-
that's
How
right
much
on the screen right now.
Maybe down in.
What about this area here?
You don't save that much time again.
You know, you save kilometers
We
worth.
know we got
You
big
get
blocks
10
here. We know we're on the rim.
You save 2 kilometers worth of driving.
You're on the rim, okay, so that may mean the blocks are the biggest ones that have been brought up to the rim, and that's kind of what we want to know from the station.
Right. But it's a long way. We're only gonna.
For now.
But you're never going to know for the rest of the EVAs whether those are things that are where the hell they're from. Here you stand a good chance of getting a variety of blocks which may have been brought up from depth, which might have sampled a section which might be complex, precious.
What we're trying to do is save the driving time and get longer time in geology if you want to go someplace else. Now, I think the best bet is to make sure that they go to someplace that they know what's there when they get there. As far as what you want to find. As soon as we find out we got 30 minutes of style, that's where we'll go. Okay. We'll deploy the 1 pound charge at there and the half pound right in there. Okay.
Let's face it, man. These guys are getting farther and farther behind.
Yeah, we're gonna have to go to.
Going to the west side of Steno is an optimistic opium dream right now.
I agree.
Powell is an unknown. We got knowns all in the area we're in. I think we ought to just stick within the striking range of hit Trident as our coring and sampling spot. Okay, well that's a minor problem with respect to doing some geology. That can cool down over next to you.
30 minutes is Steno, is that okay?
We're still discussing. That's the number we wanted to know.
We'll get at least 30 minutes of Steno, but we're going to deploy the 2 charges and we can go that way.
Okay, then go, I say we go. Well, they're backing off.
And it's on the way of the original traverse anyway, so that eliminates a little confusion there.
rim of a crater is really important.
Is there any objections to this new idea?
Now, I'll vote yes.
Okay, west side of Steno, if we can get
All right, you guys, I want you all vote the same way.
Well, we should record that there are dissenting votes, but they don't have a vote.
They don't have a vote, right. You remember there's a 4-man voting team on the geological garbage.
But I want to hear it from the geophysics and geochemists.
You haven't heard from the geophysics yet.
Well, if we go to Steno, we can get the SCD at the end. Yeah.
That's halfway out.
Decided we're going to Steno?
You get away from the walk back.
We better make sure that all falls into place, though.
Yeah, let's look at it again.
Yeah, let's look at it again.
What are you thinking you're being able to give it?
30 minutes of Steno?
I don't think we should go 30
there.
Would we?
I think it'd be worth it.
East and west side of Steno.
The west side of Steno.
Jim, we missed the numbers. If we leave at 4:28, do we get 45 minutes?
Yes,
Steno?
yes.
Great.
But don't forget, we still got to get the... Now, would you take 30 minutes of Steno?
I believe so.
I believe we would.
Yes.
I would.
I mean, it might be down to that.
So we might not get
It
away.
also gives us an EP that we wouldn't get
Take 30
otherwise.
minutes of Steno, huh?
If we start losing
That's
that
45 minutes. After that, we start cutting into the time at Steno, which we could cut down to 30 minutes and still want to stay there.
Yes.
Plus, we could get set deploy, which I think we ought to do towards the end.
Gene needs the depth of sample represented by the rim at Steno as much for his interpretation as everybody else does.
If we leave in 4 minutes, we can have 45 minutes of Steno.
Normally, they want to go back to the LSF site and check out some stuff.
Nothing to do.
They got low signal strength on the whole package. They
You can
never
do
been
that
out
at the end of
antenna.
EVA 3.
You pull the central station a lot, and we believe we're not looking at the right place.
Okay, that can be done in EVA 3 closeout. No, let's not wreck EVA 2 with
We
it.
got to go back sometime.
Well, that's pretty important though, Bill.
We got to go back anyhow to get the neutron probe.
Yeah.
Right. Let's do it then. That's obvious time.
But they'll want to go back at the beginning of EVA 3. So you got to think about
That's
that.
the old walk back, drive back constraint thing. That's silly.
What did you do with that checklist?
It's up on the screen.
Up on the screen.
Your initials are down in the lower right.
That whole
And
thing
it's in your handwriting.
That whole thing was a stratagem to get it around you.
We switched cards.
Switch cards.
Thought we acted real well. Uh-oh.
Well, why don't you prepare a hard time for us to leave?
I got that.
To get back to deploy
I got
the
it. 28. That's 5 plus 28.
5 plus 28.
Yeah, 5 plus 28, and you leave, and you'll get back and deploy to SEP.
That's 30 minutes from now. 29 and a half.
Yeah, that's 29 and a half minutes from now, but remember, they left this side a little bit late.
They're at Steno now.
Are they going to get to within 15 minutes of completing the SEP deployment?
And Jim, you better make it clear to Parker that we got to pull out at the proper time.
What I'd like to get, Dick, is a hard time to leave, and also a checklist of exactly what they've got to do. They've got to deploy that 1 pound charge, and they've got to do, that sampling priority is for the sampling part of the thing.
Okay.
We think they're there. We don't think they got the steno.
That would have been better coming right there.
No. Here's where we are, Lee. Here's steno. We turned around the corner, went down in here somewhere. There's a sort of a saucer there.
It sure looks like a hell of a lot more than mine.
That was Parker asking if we knew where in the hell they were, and I said no.
I heard it, but they're there.
Apologies for going over time. Thank you very much for your attention.
Thanks, Ben. It's always interesting and instructive to watch that amazing footage.